Hello everyone, welcome back to Fun Molecule, and this is in continuation of series of designing our own plasmid using Snapgene. In this video we are going to learn about gateway cloning. So in my previous video you have seen we discussing the restriction enzyme cloning, PCR cloning, Gibson assembly. Now in this video we'll be talking about gateway cloning and how it is different from other cloning and how it is better. So let me give you a brief of our mechanism before jumping on to our technical Snapgene build. So as you know, if you talk about traditional restriction enzyme cloning, you will start with a vector which will be digested through restriction enzyme, and you'll be simultaneously preparing for your interest gene of interest, and that will be your insert. It could be a PCR product because you will be amplifying it, or it can also be an product of a different vector, so you will be subcloning. But after that, you'll get through the restriction digestion, then the ligation occur, and the positive negative selection. These are all the methods. And then you refine the recombinants which have your insert, and then you get your clone product. But if you talk about gateway cloning, it is less labor intensive, and it will just have simple 2-3 reactions, which I'll be briefing to you, and then we can have our cloning product. So let's get to the point. If you have seen a bacteriophage infecting a bacteria, so in its life cycle, insert its genome in bacteria and it can integrate in bacterial genome. So this integration will be occurred due to their recombination between add site. So what is that add site? So if you see, if a phage genome, a lambda phage genome, wants to integrate in bacterial genome, there will be this add site. It will be defined as P for bacteriophage, attP, and there will be attB for bacteria. So the O site will be the common attachment site, common attachment spot for both the bacteria and phage, and there will be P and P prime and B and B prime. So this is the ATT attachment site. This will be our reaction. You might have seen the Pop and Bob reaction in your theory class. So let's say this will be at P and at B. This is the middle point will be the O site, and the integration will occur through recombination. So the phage has a integrase enzyme that initiate this recombination, and these products will be integrated through this. This recombination at first rate will be the BP reaction, and after the two products occur, the LR reaction also occurs. So in this video, when we will be doing the gateway cloning through Snapgene, we'll be focusing on BP reaction. So let's get started and import our NCBI sequence. So as you know how we import the NCBI sequence, we'll just go to NCBI site and we will select the database that will be nucleotide for this experiment. And P53, complete CDS, Homo sapiens. So I hope you know what complete CDS means. It stands for coding sequence of any gene you want. So let's say just we can take this P53 mRNA of Homo sapiens. We can take it as our insert in this example. We just need to have the accession number. You can copy the version and you can just copy the accession number here. So you can paste it in our Snapgene. And import. So it's asking that AB083923 is marked as linear, but it looks like a plasmid. So is it actually circular? It is actually linear, but you can also have it in circularized form, anything you want. Even if you choose linear here, you can circularize it later. And you can see this is our whole complete CDS gene, and this is ORF, and this is our gene from start to stop codon. This is its linear form. You can see it in secularized form. These are the all restriction enzymes. You can restriction sites you can see, and you can use it if you want to do restriction enzyme cloning. But we are going to a simpler way this time. So let's just go to actions here, and we'll be doing gateway cloning in BP reaction. So there we go. This will be the attB fragment, and now we are going to select. You can select as I have selected the exon, the gene out of all. You can also select it from here. It will be here from, it is this stop codon, and you can start selecting from here. That's start codon, and that's your stop codon. Now, again to map and donor vector. You can choose any donor you want. Like if you have customized your specific vector for this experiment, you can load it here. But these are some standard donor vectors. For this example, let's say I will choose P donor 22021. Sorry, 221. This will be our donor vector. You can see it has kanamycin resistant site, attP2, attP1, and CDDB. As you can see, this CDDB region will help you in the positive selection. So when the recombination will occur, this site from attP and 1 will be switched from the attB fragment that has our gene of interest, and the CDDB will be gone in the other vector. So any bacterial cell which will be having the CDDB, it act as a toxin. So it will degrade the cell by itself. So you will be getting only the recombinant bacterial cells. So it will make your selection easier. You don't have to add an extra step in your cloning. So now you have your attB fragment and donor vector. Let's to entry clone. Now what you need to do is choose the PCR primer. You can select the auto-selected primer, you can choose the direction, and you can also change the melting temperature for your specific PCR primer from here. And we'll be using the default settings, and we are choosing it as our primer. Now you'll be able to see your entry clone, which has your P53 gene, as I told you, in attL region. So as you can see, the BP reaction has occurred, and you have this region. We can also talk about LR reaction in some of our other video. If you are interested, you can tell me. We can discuss that, its mechanism and how it's performed with gateway cloning. So for this reaction, we have our entry clone, which has again the kanamycin resistant site, ORI site, and our gene of interest. As you can see, we here do not have the cDDB gene because its toxic effect will be shown in other cells, so it will help us in the selection. It will be the positive selection. You can see the reaction here, and let me shift. You can change your clone name. Let's say it's P53 clone. And we are saving this clone. Now our product is generating, as you can see, and you'll be able to see our final product here. There we go. It's our final product, P53 clone. As we expected, everything is done very appropriately. I hope you understand this reaction, the mechanism behind it, how do you clone with gateway cloning, and how it is simpler as compared to other cloning methods. So thank you and stay tuned. If you have any doubt, you can ask in the comment. And it was a special video because I made this video on request of Miss Sultana. And thank you for reaching me out. I'll be happy to help if you need anything. Thank you so much.